Hello and welcome to the fourth lecture on stereoisomerism. We are joined by Samit Tripathi, Rudra Sahu, and also some viewers from YouTube direct YouTube source. Yesterday, we had a rapid round discussion on the determination of the configuration R and S by using the CIP rule. And towards the end, we rapidly, Anil sir, namaskar. So you are the only teacher who encourages this teacher in every public activity. Thank you very much. I'm obliged to you. Towards the last, I was little, fast in explaining the configuration of molecule having two chiral centers, and that molecule has a plane of symmetry. Structurally, it is symmetrical. Structurally symmetrical. And in one of the forms, you can realize a plane of symmetry. And that too in the eclipse conformation. Conformation changes are allowed. So if I just give you this conformation or say, I have a question for you, a $1,000 question for you. A $1,000 question for you. Let me share my screen first. Have I shared my screen?
No, sir.
Okay. Let me share my screen first. Now you can see my screen.
Yes, sir.
Yeah. In the morning, I was Shiva Ghosh. Yes, in the morning, I was really not feeling well to have a class for class 9. So I abandoned that class with a lot of heavy heart. I was not able to wake up in the morning at the right time at 5 o'clock because if I have a class at 6, then I have to wake up at 5. And I saw the watch at 5, but I thought I cannot make it. So it is better to abandon that class. Yes, Siv, I'm so sorry. But now I'm feeling good. So I'm taking class 11, 12 and NEET, JEE aspirant. Yes, Sibdat, yes. Sibdat, I know Sibdat. But where is a ghost title? Yeah, I know. Are you Sibdat Ghosh? Okay, okay. Do you participate in our morning program every day? Siv? The last 3 days we were having. Did you participate that? Or you were watching the YouTube video? Yeah, yeah. I think you were watching YouTube video. Am I correct? If not, then why you were so concerned about my health? Yes. Okay, thank you. Now you can disconnect from this class because this is not meant for you. This is for higher level, class 11, 12 and above. NEET, IIT, JEE, advanced and all that. Yes, let us come back to our work, Mr. Rudra. And Ms. Tripathi. This is $1,000 question for you now. I am showing you this meso, say tartaric acid. This is a symmetrical structure and this particular form is meso. Why you say this is meso? Why this form is meso, which is optically inactive due to internal compensation? If one is R, the other one is S. So the optical rotations are compensated internally and it is optically inactive. So why do you say it is optically inactive? It is an chiral molecule.
Sir, it has a plane of symmetry.
It has a plane of symmetry. Sami, was it your answer too?
Yes, sir.
Okay, now the $1,000 question. This was not $1,000 question. The $1,000 question, if I think Miss Tripathi will try first. I want $1,000 should go to my granddaughter. I'm just kidding, Rudra. You know. Supposing I will bring the conformation to anti, which is the conformation in which the molecules really exist. This is called the anti conformation in which the molecules exist. This is a hypothetical conformation where the stability is negligible. It's unstable and no molecule will stay in this unstable conformation anytime. So this is the anti-conformation. I'm saying conformation for the mesoform. If I ask you now, how can you prove in this conformation that it is achiral, symmetrical, and therefore it is meso, does not respond to PPL?
So it has a center of symmetry.
Oh my God. Oh my God. Oh my God. I owe you $1,000. Tell your mom, dad. Yes. Were you in the same opinion, Mr. Rudra?
Yes, sir.
Yes. You know, an average guy will never ever think about it. That supposing somebody gives you this confirmation and asks you that whether it is meso or active, whether it is active or inactive, he will try to rotate it and bring it to eclipse confirmation and say there is a plane of symmetry. But I say that we need not have to rotate because in fact eclipse confirmation does not exist. It is just a theoretical thing. Rotation occurs rapidly through eclipse but doesn't remain, the molecule doesn't remain at any point of time in the eclipsed conformation, which is highly unstable. Now there is an center of inversion. White, white opposite, blue, green, green opposite, blue, blue opposite. There is a center of symmetry, you can say. So conformational changes are allowed. Now I will ask you another question, not $1,000 question, maybe $1 question. In US, in 90s and in the early 21st century, the Dollar Tree houses were very, very popular there. You know, you will get a particular shop where it is written Dollar Tree. Where, you know, in India, we say Harek Mal. 5 rupees Harek Mal, 20 rupees Harek Mal. Nowadays, 100 rupees Harek Mal, whatever you take. So there is a Dollar Tree, whatever you bring from there, it was $1 cost. And when we were going at those times in early part of 21st century, I had been in 1998. So that dollar, I used to bring all gifts from the Dollar Tree. $1, $1, because at that time $1 was really very, very expensive for us, for the Indians. Now the question is, in this confirmation, which has a plane of symmetry, okay, I want to convert this model to any one of the active one. This is meso, inactive. I want to convert it to active. What shall I make? What surgery I will make onto the molecule?
May
Yes, this time Rudra.
sir, we'll do a single switch in one chiral center.
Yes. If you make a single switch at any one of these two chiral center, any switch, one switch only, then all will be destroyed. You know, no I, no Aja, nothing. All these three elements of symmetry, at least you found sigma in eclipsed, you found I in anti. So nothing will be found here. Whatever you may try, you will not find any of the three elements of symmetry. Now a $2,000 question. Look to the molecule again. White, I have kept it above, eclipsed. This is an eclipse confirmation, but white are eclipsed. When that is done, then green lie on the opposite side, blue are also lying on the opposite side. And if you do with green, the other two will remain in the opposite side. If you do it with blue, then the other two will remain opposite to each other. So you cannot get a plane of symmetry. The question now is there any element of symmetry here which will prove that it is a chiral molecule? It's not achiral, it is chiral. It is dissymmetric. If so, then what it is? This time I have kept blue eclipsed, but green and white, they are lying opposite to each other. Yes. Your time starts now. I will be counting 10. Then $2,000 will be forfeited. This is very, very unfortunate. After having discussed so vividly yesterday, you are unable to say that which element of symmetry is present. No, you considered defeat. You don't deserve $2,000. I reduced to $1,000. I reduced to $500. Reduced to $1. So the one who failed in $2,000 will never ever try in $1 question. Now, you fools, I told you the presence of Cn, n-fold axis of symmetry, will make a molecule chiral. I also said that CN, presence of CN makes a molecule chiral dissymmetric. But that doesn't mean that every dissymmetric molecule will have a CN axis. They may not have a CN axis. It may have, but these three elements are absent. Sigma, I, Sn, they are absent. It may or it may not have CN, but this has a clear cut CN. Now see, तुम जानी पारलनी एट दीटा ऊपरे अछि, ये तार ऑपोजिट, ये तार ऑपोजिट, ये गोटे वर्टिकल एक्सिस रे मुझे 180 डिग्री बुलेइबी C2 एक्सिस रे एग्जैक्टली सुपर इम्पोजेबल फॉर्म पाइब कि नहीं?
Yes, sir.
एई वर्टिकल एक्सिस एठी जाउची पूरा वर्टिकल एक्सिस रे मु बुलेइबी 180 डिग्री एमती थिला तुम्हें आखि बुझी देलो मु ता भितर 180 डिग्री बुलेई देली देखला बेलू तुम कह सार कि आपण करना आपण कहते गोटे कौन कले बोली कि तो करना बट आई हैव डन आई हैव ऑपरेटेड दैट इज कॉल्ड C2 ऑपरेशन सो देयर इज ए C2 एक्सिस नाउ हाउ आर यू फीलिंग एंड हाउ यू नो अनफॉर्चुनेट थिंग इट इज how bad I am feeling that you are not able to detect after I have given you so long a time to think about it. Ms. Tripathi, what element of symmetry is there in this?
The CN.
Eh?
The CN.
What CN? You have to define.
The C2.
आशा कहून 180 डिग्री बुलेला माने C2, 120 डिग्री बुलेले जदि रिपीट करिवो ताले C3, 90 डिग्री बुलेले C4. Oh my God, my starting is very pathetic today. Okay. Now, can you, shall start with a new page. Can you guys tell me, I will be doing this is butane 2,3-diol. Butane 2,3-diol, which form I have drawn, whether it is inactive mesoform or any one of the active forms. Not necessarily I will be giving the Fisher formula in the way I gave yesterday. I can change it. Even if you have not learned conformation, conformation has not been discussed in detail, you can make two switches at any chiral center without changing its configuration and ensure whether you can get a plane of symmetry or not. If the identical groups remain on the same side, you can get a plane of symmetry. So whether it is active or meso. So this really pathetic.
The mesoform.
Are you kidding me, Ms. Tripathi?
Sir, it is SS.
SS कथा you don't try to outsmart me. ମୁଁ ପଚାରୁଛି whether it is active or meso. ତାପରେ ମୁଁ SS କଥା ପଚାରୁଛି. ସେ ମାନେ ଭାରି ଚାଲାକ. ସେ କହିଦେଲା SS କହିଲା ମାନେ ସାର୍ ତ ବଳେ ବୁଝିବେ ଏଟା active ଆଉ. Active or meso?
Sir, active.
ସେ କହୁନ. କାହିଁକି Ms. Tripathi OH are lying on the same side like this. Green, blue are remaining on the same side. While methyl hydrogen are remaining on the opposite side. In that situation, you can only get a C2 axis, but you never ever can get a plane of symmetry or I or SN. You can never. যদি দুইটা গ্রুপ সেম সাইড রহিলা আর দুইটা গ্রুপ অপোজিট সাইডে রহিলা তেবে সেইটা ডেফিনেটলি অ্যাক্টিভ বুঝি হেলা
Yes, sir.
Yes, sir.
even this is active and RR की SS active हेला माने symmetrical molecule रे particularly this type of symmetrical molecule, butane 2,3-diol bhalia, tartaric acid bhalia, you have to have RRSS. These two are active enantiomers. But RS, which is equal to SR, is meso. Now, supposing I will do a little bit change here. Now you tell me, Miss what it is. Miss Tripathi will say. Your time is over, Rudra.
Sir, active, sir.
एते समय लगुची परा पुणी मेथाइल मेथिल सेम साइड रे अछंती
नाइ सर स्विच करथुलु
स्विच कोन करथुलो कोन दरकार स्विच होबो मेथिल मेथिल सेम साइड रे अछंती एंड OH opposite side this vertical line is below the plane and horizontal line is above the plane and HH also opposite side એટલે એકા જીન્સ ये जहां ये सैया configuration एटा RR एटा SS हे पर I don't know but it is active. I want to identify whether it is active or meso. Meso, the question of meso arises when the molecule is symmetrical structurally, so that in one of the forms you can have a plane of symmetry. Not in all forms. These two, which I have done, I don't know whether they are both RR or one is RR, the other one is SS. What do you say, Mr. Rudra? The first one you said SS. What do you say? The first one is what? Number one
sir
is
SS. Sir SS.
number one is OH. Number two is Buddha. Because that Buddha carbon carries oxygen in its head. It is bonded to oxygen, but this carbon is bonded to hydrogen. So Buddha is second, and three is methyl. 4 is hydrogen, which is lying in a horizontal position, which is we have to apply the golden rule. So 1
sir
to 2
R
to
R
3
R. Sir R R.
anti-clockwise. Mr. Rudrani, you
Sir
are
R R. Sir R R.
R. ତମେ ତ SS କହିଲ R ହେଲା ମାନେ ଏଇଟା R ହିଁ ହବ ଆଖି ବୁଝିଦେଲେ ଏଇଟା R ହିଁ ହବ ଦେଖ କର କାରଣ ଆମେ ଜାଣି ସାରିଲୁଣି ଏଟାର ସେଣ୍ଟର ଅଫ ସିମେଟ୍ରି ସରି ଇଟ୍ ଇଜ ଆ କାଇରାଲ ମଲିକ୍ୟୁଲ କାରଣ ଦିଟା OH on the same side ତମେ ଭାବୁଛ OH ତଳେ ଉପରେ ଅଛି ବୋଲି କଣ ଅପୋଜିଟ ସାଇଡ नो दे आर लाइंग ऑन द सेम साइड बिलो द प्लेन एमिति ଏଇ ଦେଖ ଏଇ ଆରି ରିଫ୍ଲେକ୍ସନ ଏଇଟା ଏଇ ଦେଖ এই जो ब्लू ब्लू तम आड़ को जाइए तारी प्रोजेक्शन एटा व्हाइट एंड ग्रीन मु चलेलेनी ओडिया रे लेखुची किंतु इंग्लिश पब्लिक ये रे in my YouTube description I am writing English but I am conversing in Odia. That is very unfortunate. You guys are so this our projection will be here this and that means they are on the same side. In the Fisher formula, it looks as if they are on the opposite side. No. The vertical lines, even if they are miles apart, they are on the same side. Are you following me?
Yes, sir.
Ms. Tripathi?
Yes, sir.
So, এটা R হেলে এটা অটোমেটিক্যালি R হবে দেখিয়া কেমতে হচ্ছে R এটা 1 বুড়াটা 2 3 এটা 4 so 1 to 2 to 3 এটা be 1 কাই 1 then 2 then 1 2 2 then 3 3 होଉଛି ଏଇଟା anti clockwise ଏଇଟା ବି anti clockwise ହେଲା R ଆଚ୍ଛା ଏଇଟା କ'ଣ ଏଇଟା ତ active
सर ये भी R R
ହେଇପାରେ RR ଦେଖିବା 1 ବୁଢା ଟିକେ କରିଦେଲେ ଆଉ ଲେଖିବା ଦରକାର ନାହିଁ 1 ବୁଢା 3 1 to 2 to 3 anti clockwise and hydrogen now is occupying in horizontal position so anti clockwise মানে R এটা R ହେଲା ମାନେ ଏଇଟା R যদিও এটি নর্মাল রুল আপ্লাই করিବାକୁ পড়িব এটি হাইড্রোজেন ইজ অকুপাইং ইন এ ভার্টিকাল পজিশন সো নম্বর 1 এটা নম্বর 2 বুড়া 3 ক্লকওয়াইজ এন্ড নর্মাল রুল R ये भी RR ये দুইটা দেখো হোমোমার্স They are same, but they are represented in pen and paper, in formula, in Fisher formula, they look different, but they are identical. Homomers are identical configuration, but they are represented in a different way in pen and paper, identical configuration. Got it?
Yes, sir.
Now,
Yes.
supposing I will be doing this one. Uh, This is 2,3-dichlorobutane, just like butane 2,3-diol. There are two chiral centers. There can be three forms. One is meso, and the other two are optically active. So, ଏଇଟା କ'ଣ ଭାବୁଛ? First of all, decide this will have a mesoform. This structure, which is symmetrical in nature, will have a mesoform. Whether this is meso or not, we have to identify, or it is active, like the previous ones. Yes.
Sir, 2s3r.
ଆରେ କ'ଣ ମେଜୋ ନା ଆକ୍ଟିଭ? ମୁଁ କ'ଣ ପ୍ରଶ୍ନ ପଚାରୁଛି, ତମେ ଉତ୍ତର ଦଉଛ କ'ଣ?
Sir,
Sir,
meso.
meso.
ସେଇଭଳିଆ ଯେମିତିଆ ଇନଡାଇରେକ୍ଟ ଆନ୍ସର ଦେଇଥିଲେ ରୁଦ୍ରାଣୀ, ସେମିତି ଆମର ସମିନି କହୁଛନ୍ତି ଯେ ମୁଁ RS ଦିଟା କଥା କହିଲି, ଆପଣ ତ ବୁଝିବେ ବଳେ ମେଜୋ, ଆଉ ଏତେ କଥା, ଆମେ ତ ହିରୋ ମାର୍କା ଲୋକ। ସୋ ମେଜୋ ନା ଆକ୍ଟିଭ?
Sir, meso.
Why? Because chlorine opposite ଅଛି, hydrogen opposite ଅଛି, just like I showed you anti conformation. This is the one, and methyl also opposite ଅଛି. So যদি সবগুড়াক pair opposite, then they can be brought by changing the conformation to eclipse conformation, where you can get a plane of symmetry. So you can check that. Either you can find the configuration, গোটাଏ R গোটাଏ S ବାହାରିଲା ମାନେ meso symmetrical, particularly symmetrical structure ରେ, or you can see for yourself by making you want to bring methyl to this position and see whether hydrogen coming on the same side, and chlorine are coming on the same side, because methyl. So for that we have to make a sequential shift between these three, keeping the Buddha fixed, so that hydrogen will come here, methyl, because making a sequential shift among three groups attached to a chiral center will retain the configuration. It is equivalent to two switches. So methyl etic asila, hydrogen etic asila, chlorine asila, tolta to ame fix rakhiche buda taku. So you can, as a lay person, you can say, you can find a plane of symmetry here, but intuitively you can say jodi all the pairs are opposite, gote pair bhi same side re nahi, then definitely it is meso, and gote R hele gote S, and RS is equal to SR. A case re 2R 3S is same as 2S 3R. They are superimposable. That is the trick. Because upor adu gale eta kon aସୁଛି? Chlorine number 1 ବୁଢାଟା ଯେହେତୁ chlorine ସାଙ୍ଗେ ଲାଗିଛି, ବୁଢା 2 3 1 2 का 3 anti clockwise, sorry clockwise ବୁଲୁଛି, ଏବଂ ଏଇଟା normal rule, sorry golden rule. So S, এটা S ହେଲେ ଏଇଟା R ନିଶ୍ଚୟ ହବ। Chlorine number 1 ବୁଢା number 2 1 2 का 3 anti clockwise, and again golden rule R. So it is SR, which is meso. Got it?
Yes, sir.
Yes.
Now, any question?
No, sir.
Aditya, Kartikeyan. Hi. I think you are not belonging to the state of Odisha. Are you? If not, then you tell me, so that sometimes I'm using this Odia language because most of the viewers belong to the state of Odisha. But if you cannot understand Odia and you are following me, then please tell. I will Maybe sometimes I will tell in Odia, but also I will explain everything in English. James, hi. Now, interesting things will slowly and steadily will evolve. That is, molecules having two chiral centers and no PS, plane of symmetry. That means it is an unsymmetrical structure. In no conformation, no configuration, you can have a mesoform. That means, supposing I will change this one, hydrogen COH will remain same, OH will remain same, HCOH will remain same. Instead of OH here, I will make a methyl. I will make a methyl. That means this molecule, if you can break your head into 100 pieces, will never get a mesoform. Because, this is an unsymmetrical structure. In no configuration, you will find a PS, plane of symmetry. So in that case, you get 4 optical isomers. All are optical active. RR-SS, it is one pair of enantiomers. RS-SR, they are not the same. They are also enantiomers. Let's see. So you just have its mirror image, which you can switch. Now my $5 question, how to convert one enantiomer to another enantiomer, Mr. Tripathi?
So
How to convert one enantiomer? This is chiral, no plane of symmetry, no sigma, no I inversion center, no alternating axis of symmetry. So this is a chiral molecule, and we have its mirror image, which is non-superimposable. So how to convert?
So by one switch,
By making one switch
sir, at one chiral center.
at one chiral center.
Sir, like one switch at each chiral center.
Ah, are you down today with some sickness? You are not looking good. I mean, are you starving?
No, sir.
If so, then ask your mom to feed you something. You must be very spirited, energetic. And to hear you, I have to increase the volume of my speaker phone to the highest. You also produce a little more sound, more pitch, so that and if I can make a mirror image of this, of to look to the general public that it is a mirror image, I will interchange between left and right. Otherwise, in principle, you can interchange these two here, these two here, these two here. Any one switch at each chiral center. Any one switch at each chiral center, then you will generate its mirror image, which is non-superimposable. Just like this one, this was meso. I make one switch as Rudra has pointed out, then I will get an active one. Whether RR or SS, I don't know. But I will get an active one. I cannot get any of the 3 elements of symmetry, but I will get C2. I have told you, because had I not taught to this advanced program, then I would have definitely refrained myself of talking the presence of C2 in this active form. Now, what I was saying is, to convert this enantiomer to the other, then I have to make one switch here or any switch here and get another one. You will find you cannot superimpose, but you can correlate the two as their mirror images. You cannot superimpose. So for good optics purpose, let me concede to, you know, so these is as a DL pair. I don't know whether which one is D, which one is L, but I can dare say, you can dare say, which is RR and which is SS, or it is RS SR. That you have to decide. Tell me whether it is RR SS pair or RS SR pair, because its IUPAC name is unique. You have to go in one way according to IUPAC, not in the other way. Just like the symmetrical compound, you could have either started from this side or that side, will give you the same name. Carboxyl is senior to the Buddha, no doubt, because in carboxyl, carbon is bonded to as if 3 oxygen. But this Buddha, the carbon is bonded to 2 carbons. So 1, 2, 3, and golden rule you have to apply without much. Yeah. Both of you are looking very, very slow today. Yes, anyone who are watching in the YouTube, many are watching, can tell me what are the configurations. According to IUPAC naming, you have to go this way. 1, 2, 3, 4. This is 2-hydroxy 3-methyl butane dioic acid. You cannot go in the other way. It is fixed. So you have to say 2 something, comma, 3 something. That is unique.
Sir,
And this
2 or
Sir,
3.
yes, sir.
no, Miss Sami.
Sir, 2 or 3s.
Rudra, is she correct? You agree with her?
Yes, sir.
Are you sure?
Sir, it is SR.
2S3R.
Sir, SR.
What is her? You tell according to the IUPAC, locant. 2, 3.
2S 3R.
Now, do you agree, Miss Tripathi?
For me, it is 2 or 3s.
Okay, let us. पानी के पानी दूध के दूध पता चल जाएगा अभी. देखो, number 1 is OH, number 2 is OH, number 3 is this big one. 1 to 2 to 3, it is coming clockwise, and hydrogen is lying in a horizontal position. So the opposite rule, the golden rule, as we funnily say. So clockwise means R. So 2 is, clockwise is S. Golden rule, clockwise is S, anti-clockwise is R. So clockwise it is going, so it is S. You got it, Miss Tripathi? You got wrong.
Yes, sir.
You are not following because unless you follow both the rules, it will be difficult, in advanced problems. How many times you will be making 2 switches and bring it to the vertical position and then start using the normal CIP rule? How many times? That is why 1 to 2 to 3 it is going clockwise, but this is the golden rule, so it is S. Then we cannot say whether it will be, the other one will be S, because both SS, SR, RS, all are optically active. There is no plane of symmetry. So this is S. Now let us do this. Carboxyl is number 1 here. And the group Buddha is number 2, methyl is number 3. So 1 to 2 to 3, anti-clockwise golden rule. So R. So this is 2S, 3R. And undoubtedly, by closing your eyes, you will say this will be 2R, 3S, because you have inverted the configuration in a sequential manner. This is carbon number 1, 2, 3. So you have inverted, so it has to invert its configuration, 2R, 3S. So these are enantiomers. And how to convert to the other diastereomer? Just like you are converting active to meso, meso to active by making one switch at any one chiral center, you do the same thing. Make one switch at any one chiral center, you convert this pair into one of its diastereomer. One will remain same, the other one will change. So in that case, it will be giving you diastereomer. So I am changing the first chiral center. I am just making a switch between COH and H, only one switch, and the other I am keeping intact. So this is obviously I have inverted the configuration of second carbon. So this has become R, this is R. There is no need to assign the configuration again because you have inverted the chiral center number 2. So now you make a mirror image. Just in interchange between left and right. But in principle, you can interchange between any two groups at each chiral center. Because I have told you repeatedly to convert one optical isomer to its diastereomer, you have to change only at one chiral center. Interchange or make a one switch at any one chiral center. But to make its enantiomer, then you have to make switches, one switch at each chiral center. So this is HCOH, this is COH, H, and this will remain the same. So that if this is RR, this is undoubtedly SS. This is also, this is 2R, 3R, this is 2S, 3S. So this is also a DL pair. So, how many diastereomers? You know, any one of this, they are related as what? What?
Diastereomer.
So you have you have learned, permutation, combination, and other You tell me how many pairs of diastereomers you can generate? How many pairs?
Sir, 4 pairs.
4 pairs. Because first one was 2s 3r. So 2s 3r remaining constant, you change these two. And 2r 3r. This one. So this remained constant. So this only changed. So this is one diastereomeric pair. And what is the second pair?
Sir, 2S.
2r 3s, the second one. 2r 3s remaining constant. No, let us do one thing. 2s 3r ame nele and 8 nele puni 8 bi naba nai ago sariba sei ekka jinsu constant rakhiba in a systematic way ame sariba 2s 3r ame fix rakhiba and arota naba 8 2s 3s so that 2s constant rohila ei gota ko different asila ethi एटा डिफरेंट आसिला एटा कांस्टेंट रहिला ये गला ये अनदर पेयर थर्ड पेयर कोन हबो
Sir, 2R 3S.
सेटा को
2R
नबा
3R.
एटा को नबा 2R 3S टा को नबा जेमती करि परिबो तमे सेमती किछि हार्ड एंड फास्ट रूल नाही 2S 3 कोडा नबा 2R 3S टा नबा ता संगरे नबा यार प्रथमटा कोन 2R
3R.
3R एथरे रहिला कोन कॉमन ना 2R रहिला कॉमन बाकी ए दीटा अलगा रहिला ये गुटे पेयर एंड फाइनली द फोर्थ पेयर विल बी सेम 2R 3S टा को हमें आगुरु नहीं छे से 2R 3S को रखी करी हमें आरटा नबा दैट इज 2S 3S ये आगुटे पेयर सो एथरे 3S कांस्टेंट रहिला 2R 2S से माने अलगा रहिले. So I have already defined yesterday that in diastereomers, at least one chiral center is identical. At least one, maybe two. In multiple chiral center, there may be 2 chiral centers identical. One chiral center maybe opposite. But if all are opposite, then that will be enantiomer. If there are 4 chiral centers, and at each chiral center successively, systematically are being inverted, then you are getting its enantiomer. If at least one remains same, 3 are opposite, then they're diastereomer. 2 opposite, diastereomer. 3 opposite, diastereomer. 4 same, it is homomer. So at least one should be same. Then only you will get diastereomer. Now let me give you another question, a $1,000 question to identify. Before I do so, let me tell you what is the concept of erythro and trio. That concept has come from the carbohydrate chemistry, which is used in other configurations. That happens when two pairs of groups are identical, and one pair different. The example we gave. In that case, the meso counterpart is called erythro. For example, here OH methyl and the other are same on the same side. HH on the same side, COH on the same side. 2 pairs are on the same side, but the non-identical pair are also on the same side. There will be one non-identical pair, they also will remain on the same side. This is called erythro. That has come from erythros, the carbohydrate erythros. I will tell you later. Erythro, of course, this is a trivial name. Sometimes you might get a question from any source. That is why I told, but it has got a specific RSSR. Can you identify the RS configuration of this? According to nomenclature, you have to go this way. 1, 2, 3, 4. 2-hydroxy, 3-methyl butane dioic acid.
So 2s3r.
Now, this erythro is a trivial thing. If you write 2s3r, that is more concrete than erythro. But sometimes you are given erythro, so you have to know that if I keep the 2 identical pairs on the same side, the non-identical pair should be also kept on the same side. So is it 2s3r, Miss Master Rudra?
Yes, sir.
Yes, let me check. 1, 2, and the bulky group 3 clockwise, and this is golden rule S, and this is 1, 2, 3 anti-clockwise, and again golden rule R. Correct. And if you make an exchange, at any one, so that you interchange here and keep every other thing same, that means when you keep the non-identical pair on the same side, the identical pairs, they remain on the opposite side. This is called trio. Trio D and L. This is trio. Its mirror image will be 3A DL. If this is D, its mirror image we have not drawn, it will be L. Right? This only one enantiomer we have drawn. The other one will be 2R3S, just the opposite of every one. But this one, since we have changed the configuration of second carbon, also without further assigning the configuration, what shall we write?
Sir, 2R3S.
2r3r.
So this will be 2R3R, and its mirror image will be what?
No, sir.
And its mirror image will be 2S3S, which we are not drawing. 3OD and L. This is 1. I don't know whether 2 or 3 are in this compound is D or L. Nobody can know unless he has a prior knowledge about this. We can't predict. You can't guess. You can't guess unless you perform the polarimeter experiment. You got it?
Yes, sir.
Yes, sir.
Let's go to the 3 chiral centers. Molecules containing 3 chiral centers. Case 1, symmetrical structure. That means can have a PS. In one of the forms, you can get a PS, plane of symmetry. Structure is symmetrical. So mesoform will be available if symmetrical structures are encountered in one of the, optical isomers. Maybe it be a diastereomer. You will visualize that. Interestingly, it has got 2 subcases. So let me not write this. Let me write bit 1. In bit 1, there are 2 possibilities. Case 1, where n, oh no, it is better. After 3, then I will talk about 4. Okay. 3, let me complete. No, this is case 1. Case 1. So because I have already defined 3, so the case of 3 is very interesting. And sometimes you will be really puzzled. You know, people used to ask us, sir, how there are 3 chiral centers? This middle one is not a chiral center. I say, yes, you are true. But the middle one can also be a chiral center. That is why this phenomenon is called pseudo symmetry or pseudochirality. What is that? Now see, as such, you can visualize this is a mesoform. As a lay person, the plane passing through the middle carbon, chiral carbon, carrying this carbon, hydrogen and chlorine sitting on this plane, that is a PS, and OH will reflect each other, hydrogen will reflect, methyl will reflect. So this is a mesoform for a general lay person, right? Got it?
Yes, sir.
But interestingly, the middle one is a chiral center. Why? If you assign the configuration, if this one will be coming R, this one will be coming S. I told you R has a greater priority than S. In the CIP rule, just like deuterium has a greater priority than hydrogen, R has greater priority than S. And cis has greater priority than trans, as I have told you. Now find out the configuration, this one. এবং তরটা
Sir, S. Sir, S and R.
just a minute. কোন উপরটা, what is this, the top one?
Sir, S.
Sir,
S
S.
for R.
because OH is number 1 and this entire Buddha is number 2 and methyl is number 3. So 1 to 2 to 3 is going clockwise and it is the golden rule. So this is S. And what is this? This last one.
Sir, R.
Because number 1 is OH and the Buddha, the entire Buddha is number 2 and 3. So this is going anti-clockwise, golden rule, this is R. So R and S, they're different. Although it looks like they're same, this group same, but since it is a chiral center, if its configurations are different, then they have to be treated as different. So this one, in this condition, is chiral. And this condition is chiral when it is meso. The molecule is meso, optically inactive, because it is having a plane of symmetry passing at the middle carbon. But this middle carbon will have a configuration. Can you find the middle carbon's configuration, whether it is R or S? You have to look to both Buddhas.
Sir, S.
Chlorine is the number 1. Then between R Buddha and S Buddha, बूढ़ा का मतलब जो ओडिया नहीं समझ पाते हैं, बूढ़ा तो हिंदी में है, ये बूढ़ा बूढ़ा होगा तो तेरा बाप. एक मूवी था अमिताभ बच्चन का, बुढ़ा होगा तेरा बाप. सो एक बूढ़ा आर, एक अदर बूढ़ा एस. Then you look to chlorine, then to Tala Buddha, then Upara Buddha. Then it is going clockwise. Clockwise, but golden rule. So, kaun?
Sir, S.
S. But since it is a pseudo-chiral center, every time it is not chiral. The moment we will change, switch once at any one of the top and bottom chiral center, it becomes either RR or SS. This will lose chirality. That is why this is a pseudo-chiral center. Anyway, in this position, this is S, therefore it is given a small s. The designation is not capital S, this is small s. So this configuration is SSR. And there will be another meso. In this particular case, there will be 2 mesos. If you make a switch between chlorine and hydrogen, let chlorine be here, hydrogen be here, and keep everything fixed. This is also a meso. This is meso 1, this one is meso 1, this is meso 2. But this is S, this is R, no doubt. But this is, the middle one is not small s. It is what? C chlorine, then the Tala Buddha R, then Upara Buddha S, then is going anti-clockwise and golden rule. कौन है टाला?
R.
Switch कली पर switch कला माने configuration टा उल्टी ही गला. So why are you forcing me to talk in Odia? Once I become irritated, I talk in Odia. So this is R. So this is S R R, and this is, there are 2 mesoforms. But interestingly, mesoform has 3 chiral centers, really 3 chiral centers. But if I make a change, any one change, the upper one, say I will interchange between this and this. So since I am inverting the configuration and keeping everything same, and there is no PS. This is optically active, no PS. And the upper one, since I have changed the configuration, the upper one is R and the lower one is R. So both the Buddhas are identical. So in that case, this is achiral, this this carbon is achiral, not a chiral carbon. Only two are chiral. And then you can have a mirror image. Just interchange between these two. And for optics purpose, I am interchanging, but there is no need because this is not a chiral center, so switching has no importance at all. Even if you don't switch, they'll not superimpose. So just for sake of looking like a mirror image, so I am switching, but no switching is required because it is not a chiral center. So if this is RR, this is SS, and these are the only two active forms. So two active forms and two mesoforms will be there in a molecule which is symmetrical in structure, and there will be two mesoforms. Mesoform has three chiral centers. The middle one is a chiral one. It is therefore called pseudochiral center, and this phenomenon is called pseudochirality. And in the active forms, the middle one is achiral, but this one is RR, the other one is SS. Two active forms. Got it?
Yes, sir.
Now it's high time, before I have explained this pseudosymmetry and everything I have done. Now write down formula for finding number of optical isomers. This formula will help you whether there are 3 chiral centers, 4 chiral centers, 5, doesn't matter. Write down. In the meantime, let me fill up some fuel to my tummy. If the structure is unsymmetrical, if PS is not possible, then there will be no mesoform. The total number of optical active form is 2 to the power n. N is the number of chiral centers. So the number of enantiomeric pairs will be divided by 2. I have given you an example. We are having 2 chiral centers, which is the number of chiral center n is equal to 2, and this is unsymmetrical. This here is methyl, that here is ethyl. So 2 to the power 4, RR, SS is one, RS, SR is the other. And you know one of them and one of these will be related as diastereomers. I have given another example having 4 chiral centers, but the 2 end groups are different. This end group is hydroxymethyl, this is aldehyde. So this is an unsymmetrical structure. 2 to the power 4, there will be 16 total optical isomers. All are optically active, and there will be 8 pairs. 8 pairs. And each one of the members of the pair with other pair, they are related as diastereoisomers. Got it?
Yes, sir.
A molecule like this has 3 chiral centers. 2 to the power 3, 8. So 4 pairs. Written?
Yes, sir.
Then symmetrical structure. In that, there are 2 cases. N is even. 2, 4, 6. The formula is different. Number of optical active forms is 2 to the power n minus 1. So the number of enantiomeric pairs is divided by 2. And the number of mesoforms will be equal to 2 to the power n by 2 minus 1. Yeah. The first example I have given the tartaric acid having two chiral centers, which is even and its symmetrical structure. That will be a mesoform. The number of mesoforms according to formula is 2 to the power 2 by 2 minus 1. 2 to the power 0 is equal to 1. So there is one mesoform Rs which is equal to Sr. They are superimposable. And 2 to the power n minus 1. So that is equal to 2. One pair RR and SS. I got it? Bekilo?
Yes, sir.
Yes, sir.
I have taken an example of 2 and 4. Both are even. And the number of mesoforms will be 2 according to this form. 2 to the power n by 2 minus 1, you find it is 2. And the number of active forms will be 8. That means 4 pairs. I have shown here water having 4 chiral centers will be RR, SS, SS. Then I have changed one R to S in the beginning. Then it's enantiomer. Sequentially changed. Then I have brought S to the second position. Then sequentially changed another pair. And then 2S and 2R. Then RRSS, they are, this is meso because in the middle you will find there will be having a PS. So SSRR and RRSS they is a meso, and SR, RS will be also meso. There will be 2 mesoforms and 4 pairs of enantiomers. So total 8 forms, 8 enantiomers. That means 4 pairs and 2 mesos. I have already spelled out. Jaha kole bhi repetition hoga. Only these are the possibilities. Clear hai?
Yes, sir.
Don't worry. Then, have you written this? Or have you written this?
Yes, sir.
When the structure is symmetrical, but the number of chiral center is odd, like 3 that we discussed for pseudochirality. The pseudochirality phenomenon comes when n is equal to odd and the structure is symmetrical. And the formula is very interesting. Number of optical activers 2 to the power n minus 1 minus 2 to the power 0.5 n minus 0.5. And the number of enantiomeric pairs will be divided by 2. The number of mesoforms is the second term. Is the second term of the optical active forms 2 to the power 0.5 n minus 0.5. I have given two examples. The example which I took, only the difference was I took methyl and here there is carboxyl. But the first example I have taken CHOH, not CHCl. That also will be a pseudochiral center when one is R, the other one is S. Not necessarily it will be CHCl or some other group. It can also be CHOH. So there will be one pair of enantiomers, RR and SS. At that time, the middle one will be achiral, but there will be two mesoforms. According to formula also, you will find two mesoforms. It will be RRS and RSS. And the middle one has to be distinguished by writing in small letters. And you calculate. Don't copy. You apply the formula and calculate the number of active forms and number of mesoforms. Applying the formula, right?
Yes, sir.
Over.
Yes, sir.
Yes, sir.
Now I have a question for you. Indicate how many optically active isomers, and how many mesoforms each of the following can have. तो formula पके मत कहयो. First one को केस रे पड़िबो. Symmetrical odd ना symmetrical even.
Symmetrical odd.
Pseudochiral हेले भी ता consider करिया पड़िबो. जेले rule करा जायछि pseudochiral ने हेले भी ताको गुटे गणिबा को पड़िबो. That has to be taken into account. Odd हवा को पड़िबो. ननी ताको जदि consider करिबो तमे कहबो नाही तो सर आर जते बेले active रे सेटा होनी achiral ताको काई नबा. But सेटा होउछि तो meso बेले. But so you have to consider that and make it odd. So this will be symmetrical structure with odd number of chiral centers. So these are the three chiral centers. So what is the formula? Who can tell me?
Sir, 2 to the power n minus.
Symmetrical, n is equal to odd. तीनटा. कौन formula को देखिवा? Active forms ର formula कौन?
Sir, 2 to the power n minus 1 minus 2 to the power 0.5 n minus 0.5.
So এটা কলে 3 minus 1 0.5 into n होची 3 minus 0.5. केते आसला?
Sir, 2.
अरे एटा 1.5 1.5 minus 2 to 1. So this is 4 minus 2 is equal to 2. So this is RR and SS. हाँ कि नहीं?
Yes, sir.
And mesoforms, how many mesoforms? What is the formula? The second term, 2 to the power 0.5 n minus, minus 0.5. जोड़ा बाहर चला 2. So only 2. That is R, S, capital S, whatever that Lanza de those to distinguish. And R, small r, S. Got it?
Yes, sir.
Yes, sir.
Then B को formula पढ़िबो. Is it a symmetrical structure or non-symmetrical structure? And tell me how many chiral centers are there?
Sir, 2 chiral centers.
Yes. hydroxymethyl, this carbon is not chiral. There are two hydrogen here. So only this one is star, this one is star. You used to give a sign of asterisk for chiral centers. So there are two chiral centers and this is unsymmetrical. This side is methyl, this side is hydroxymethyl. So which formula you will apply? There will be no mesoform.
Sir, 2 to the power n and 2 to the power n minus 1.
N minus 1 कौन?
Sir, enantiomeric form.
Are you kidding me? Total number of optical isomers को formula पढ़िबो?
Sir, 2 to the power n.
minus
Allah
one.
ଆଉ କଣ କହୁଛ? 2 to n minus 1 ମୁଁ pairs ପଚାରିଛି. Automatically active form total ବାହାରି ଗଲା ପରେ divided by 2 କଲେ the number of pairs ବାହାରିବ. So I am not interested. How many optical isomers you will have?
Yes, sir. Yes.
କେତେ?
Sir, 4.
2 to the power 2 4 କଣ କଣ କହିଲ? ଚାରଟା ଯାକ configuration wise ମତେ କହିଦିଅ. So how surprising ଆମେ ଏତେ କଲୁ ପରା ଦିଟା different chirals I mean it's an unsymmetrical molecule ଆମେ କଲେ ଆଉ ସେଥିରେ erythro thrio ବି ଦେଖିଲେ ସେ case ରେ what
Sir, S R R S R R S R R S S.
ସେ କହୁନ ଗୋଟେ pair ହେଲା RRSS ଆଉ ଗୋଟେ pair RSSR but এটা unsymmetrical RSSR they are not superimposable like meso so RR ସାଙ୍ଗେ ସାଙ୍ଗେ କହିବା RRSS RSSR ହଁ କି ନାହିଁ ଆଉ ତିନିଟା ଚାରଟା ହେଲେ ଟିକେ difficult ହବ କହିବା ପାଇଁ ତମକୁ କାଗଜ କଲମ ଦରକାର ହବ ଯେମିତି ଚାରଟା ପାଇଁ ମୁଁ କରେଇଥିଲି RRRR SSSS ଗୋଟେ pair ହେଲା ତାପରେ ଗୋଟେ ଗୋଟେ ଚେଞ୍ଜ କରିକିରି ଦେଖିଲି କହିଲି କେତେଟା ମେଜୋ ଦେଖେଇଲି ସେଟା କରି ହବନି କିନ୍ତୁ ଦିଟା ପାଇଁ କଣ ଅଛି ଆଚ୍ଛା ତୃତୀୟଟା କଣ ଆଚ୍ଛା ଏଥିରେ କେତେଟା ମେଜୋ ଫର୍ମ ରହିବ ମିସ୍ତ୍ରୀ ପାର୍ଟି କହିଲ B ରେ active forms total 4टा 2 to the power 2 मेजो फॉर्म कितना
Sir, 2.
Sir, no major
oh
form.
my god
Sir, 0.
ସେଇଥିପାଇଁ ମୁଁ ତୁମକୁ ପଚାରିଲି ତୁମେ କହୁଛ କଣ ନା 2 ଏ ଅନସିମେଟ୍ରିକାଲ ସ୍ଟ୍ରକ୍ଚର ରେ मेजो फॉर्म 0 there cannot be any plane of symmetry because the structure is unsymmetrical एपटे गोटे ग्रुप सेपटे गोटे ग्रुप then third one in fact the third one is a carbohydrate monosaccharide which is an aldohexose which aldohexose I tell you this structure will have how many possible pairs this time I'll be asking how many possible active enantiomeric pairs and how many mesoforms
Sir, 16 optically active, 8 pairs, 0 major forms.
precisely it is an unsymmetrical structure epote hydroxymethyl eti aldehyde and there are 4 ago star kar do ye gote star this is another star this is another star this is another star so there are 4 chiral centers 2 to the power 4 is equal to 16 all total 16 forms active forms and how many pairs 16 by 2 8 pairs and one pair is glucose D and glucose L this is an aldohexose structure has 8 pairs like glucose galactose talose iodose and mannose glucose is one and I will draw the structure the configuration of glucose D glucose You will tell me sequentially what are the configurations according to the nomenclature, carbon number or the locants. Now, what about the and mesoform 0? What about D?
Sir, sir, eight total
This is
optically active.
this is what? Symmetrical or unsymmetrical?
Sir, symmetrical with
Now
even number.
see, Miss Tripathi, now see there is a plane of symmetry not passing through any carbon atom. When n is equal to even, then the plane of symmetry in the mesoform will be passing in between bonds at the midpoint, but in between bonds it will pass. So this side chlorine, chlorine and OH, OH. So such a molecule is symmetrical. Had there been, supposing this side Cl, this side Br, even if this is carboxyl, then also it is not a symmetrical molecule. I have deliberately given a symmetrical molecule with n is equal to even. N is equal to even L formula कौन कही n is equal to even L and symmetrical structure पाई
Sir,
कौन
2
थिला
to the power, sir, 2 to the power n minus 1.
and mesoforms
Sir, 2 to the power n by 2 minus 1.
yes n by 2 minus 1 so formula रे केते बाहरला एटा
Sir, total 8.
active total केते बाहरला
8.
8 2 to the power n minus 1 4 minus 1 the one 8 4 pairs ଆଉ mesoform केतेटा
Sir,
n
2
by
to the
2
power,
minus 1
yes, sir,
केते केते टिके वॉइस कटुची हां टिके नेटवर्क
data,
प्रॉब्लम हां
sir, data,
eta
2.
2 mesoforms and 8 active forms, that is 4 pairs. And I have given you not given. Okay, at this point of time I would like to draw what is D-glucose. This one is aldehyde, this one is hydroxymethyl, and there are 4 chiral centers. And the first one chiral center OH on the right, the second one OH on the left, third, fourth OH on the right. So can you find out what will be the configuration? This is carbon number 2, 3, 4, 5, 1, 6. They are chiral. So can you find following the same rule? Remember that, the Buddha ones are definitely senior to, this carbon is a double bond. So double bond means there will be, carbon is bonded with, two oxygen atoms. But supposing you take OH, this one, this is aldehyde, this is H, and entire Buddha to assign the configuration of second carbon. So OH is number 1, aldehyde is number 2 because this carbon is bonded to 1 oxygen and 1 carbon. So this is bonded to two oxygens. So number 1 is OH, number 2 is aldehyde, Buddha is number 3. So 1, 2, 2 to 3 anticlockwise, and this is golden rule. Kaun hobo?
Sir, R.
So 2 configuration is R. Then if you are using a pencil, you used to remove this box, Buddha box. Coming to the third carbon, chiral center. So here the 4 groups are OH is number 1, and between the upper Buddha and lower Buddha, which one will be senior? Tell me. ऊपर बुढ़ा रे कार्बन संगर ये भी कार्बन बट ये कार्बन संगर लगे ऑक्सीजन वाला कार्बन ये जो कार्बन लगे गोटे ऑक्सीजन वाला कार्बन आ गोटे कार्बन ये गोटे ऑक्सीजन वाला कार्बन ये दीटा ऑक्सीजन वाला कार्बन सो मन रखी था ऊपर बुढ़ाटा सब सीनियर तल बुढ़ा अपेक्षा सो कौन हम ताले 3 नंबर टा
Sir, 3 number टा भी R है.
OH नंबर 1 नंबर 2 ऊपर बुढ़ा नंबर 3 तल बुढ़ा क्लॉकवाइज एंड इट इज केमती केमती तमरो आर हैला गोल्डन रूल पके केमते आर हला आउथरे कर
सर सर ऊपरटा 2 हो ना
ऊपरटा पर आगो ओएस टा नंबर 1 ना देखियो पड़िबो एई कायरल सेंटर कहार बाहर करछ ना 3 नंबर रो 3 नंबर रे ओएस लागि छी सो ओएस टा नंबर 1 देन 2 3 पोजीशन पाई दीटा बुढ़ा कंप्लीट करिवे ऊपर बुढ़ा तळ बुढ़ा ऊपर बुढ़ा नंबर 2 आल्डिहाइड संगे लागि छी बोली तळटा आल्डिहाइड संगे लागिनी CH2OH संगे लागि छी तेणु सेटा होची नंबर 3 सो 1 होची OH देन 2 देन 3 क्लॉकवाइज बोलुची क्लॉकवाइज एंड गोल्डन रूल कोन हो बेटा
सर एस हो
ताले कोन पई तुमे आर कहलो
सर
मिस
मो
त्रिपाठी
उल्टा
त्रिपाठी बुझिलो तो मिस
Yes, sir.
3 टा कोन होबो
Sir, S.
सर एस
यस देन 4 देखिबा एटा लिबी दबा 4 रहूची OH नंबर 1 एगेन ए ऊपर गोटे सब ऊपर सीनियर कारण एंटायर होल बुढ़ाटा को जदि देखिबा हमें ए कार्बन रे गोटे ऑक्सीजन लागिची गोटे कार्बन लागिची आउ ए कार्बन रे गोटे कार्बन ऑक्सीजन लागिची तापरे आमे जदि एटा समान हे गला तापरे ए कार्बन को ऑक्सीजन गोटे लागिची किंतु ए कार्बन को दीटा ऑक्सीजन लागिची तेणु ऊपरटा सब सीनियर तेणु नंबर 1 देख ऊपर देख देन तळ देख कौन आसुची 1 2 and this is 3 1 2 3 anti-clockwise आउची and again golden rule कौन होबो
Sir, R.
R
आर
and finally fifth रो configuration देखिबा याकु मु पुनी लाइन स्ट्रक्चर आज कहिबी आउरी इजीली तमे बाहर करिवो लाइन स्ट्रक्चर रे एटा फिशर फार्मूला रे लाइन और जिगजैग फार्मूला टा मु कहिबी तुमको एटा कोन नंबर 1 हो एटा एंड एंटायर बिग बुढ़ा डेफिनेटली सीनियर कहना ए कार्बन को कार्बन गोटे ऑक्सीजन लगी ए सॉरी कार्बन लगी आउ ए कार्बन को कार्बन लगी ए कार्बन को कार्बन लगी पुणी ए कार्बन को ऑक्सीजन आ कार्बन लगी ए कार्बन को गोटे ऑक्सीजन आउ सब हाइड्रोजन लगी से बुढ़ाटा सीनियर हो जाउची सब बेले ट्रिक होची ऊपर बुढ़ाटा सीनियर सब बेले सो 1 ऊपर बुढ़ा 2 एंड देन CH2OH 3 सो 1 to 2 to 3 एंटी क्लॉकवाइज ताले एटा कोन
सर
एंड
आर
गोल्डन R so 2R 3S 4R 5R hele jayenge glucose and that is I will tell you capital D and capital L the significance of capital D and capital L and this is called D and fortunately this is plus glucose जोटा को आमे खाउचू किंबा आमे potato or any starch जातीय खाद्यरु by hydrolysis you are getting glucose and that is being oxidized cellular respiration is responsible to give us energy and if you take a lot of potato and rice then it will stay at your tummy and tummy will be more because you are not doing the adequate exercise to convert it to energy. If you do that, then you take as much rice as possible, but you run, jog, then nothing will happen. So, what I was saying is, now see, we have done it before in one class. I will just tell you the zigzag formula now. So what we have done for the D-glucose is this. Same thing we have done here. This is 2R, 3S, 4R and 5R and that is plus. Okay?
yes sir
Now at this point of time, I will speak capital D, capital L notation and then zigzag formula. Because we have to complete uh, optical activity due to chiral centers. Then chiral axis. Yes. Capital D and capital L notations are used in carbohydrate and alpha amino acid, which are obtained from proteins. Because there are 20 normal alpha amino acids that make proteins, obtained from proteins. These notations are used in carbohydrates and alpha amino acids. Now, it has started, the origin is, glyceraldehyde. This is the first simplest monosaccharide carbohydrate. I'm not going to discuss details about carbohydrates, but I'm saying this is D-glyceraldehyde. Aldehyde, according to the rule, that the oxidized group is to be kept at the top in the formula, in the carbohydrate formula, CHO, and the reduced group will be in the bottom, CH2OH, and this is HOH. Had it been CH2OH, this would have been glycerol. But since the one of the terminal CH2OH has been converted to aldehyde, this is called glyceraldehyde, which you can call 2,3-dihydroxypropanol. This is very fondly called glyceraldehyde. And this is containing one chiral center. And this is called aldotriose. This is the simplest monosaccharide carbohydrate. And OH is towards the right. And that is in fact D, that is plus. And its mirror image, its enantiomer is L minus. But as we continue to build up higher and higher monosaccharides with more than one chiral centers, 2, 3, 4, 5, it was found that the OH, the bottommost chiral center, which is lying to the right in the Fischer formula, that particular structure, is not small d or plus. It may be minus. Therefore, a rule came into being that let us identify the pair, the enantiomer, in which the bottommost chiral center, OH, is lying to the right in the Fischer formula. We call it capital D. So in this is also capital D. And in this case, only D is plus and L is minus. In higher carbohydrates or monosaccharides, which are called simple sugars, capital D and L terms are used only when the bottommost chiral center, the OH, is at the RHS, right hand side, in the Fischer formula. In the FF Fischer formula, it is D, and if it is at LHS, then it is L. So again, I have to write there is no fixed relation between just like RS and small d small l or plus minus, they do not have any fixed correlation. Similarly, there is no fixed relation between capital D, capital L with plus minus or small d, small l. If the bottommost OH is lying to the right, then it will be D. And if that is D, its mirror image will be L. D and let me tell you, D and L are enantiomers. Now, I am saying that since unfortunately the D glucose is capital D because the bottommost is this is the oxidized group aldehyde, this is the reduced group hydroxymethyl, and here the bottommost group is to the right, and therefore we write a D, whose configuration is 2R, 3S, 4R, 5R, which we have done. But that is D because OH, the bottommost OH is at the right. And fortunately, the polarimeter said it is plus glucose. And its mirror image, if you invert at all the chiral centers, sequentially you just make H and OH, H. This is OH, H, OH, H. The bottommost now is on the left side. So this is L minus glucose. Since D was plus, it is minus. But in some cases, you will find, many cases, you will find D is minus. Yes?
Sir, in third carbon, we haven't made switch.
Oh, I'm so sorry. I'm so sorry. Thank you so much. And I will show you now. Have you written down?
Yes, sir.
Yes, sir.
I will show you here, which we will study in carbohydrate chemistry later. D and L notations are given only, in amino acids, I'll tell you after some time. But see, this is glyceraldehyde. Fortunately, started from there. D is plus and L is minus. And then one extra chiral center will make it aldotetrose. One is erythrose, one is triose, from which this general term trio and erythro have come. In erythro, when the non-identical groups aldehyde and hydroxymethyl are on the same side, the two identical pairs are also on the same side. It is erythrose. And therefore, in other compounds, similar compounds, similar type, two pairs should be same, identical pairs, and one pair will be not identical. The trio and erythro concept can be used in a broad manner. But you cannot say whether it is RR or SS or RS or SR. You can say that it is a one of the erythro enantiomer. Now, here D is minus. And now the new chiral center which has been generated on the PT, on the back of glyceraldehyde, in this one, D-glyceraldehyde, that remaining same, we just change OH to the right is erythrose, and that is found to be minus by polarimeter, and OH to the left, that is called triose, that is also minus. D, both are minus. And each has its own enantiomer, capital L. And that will be in this case plus and also in this case plus. I have not drawn the enantiomers because there are two chiral centers, 2 to the power 2 is 4. There will be two pairs. I have only written the diastereomers and its corresponding enantiomer I have not written. Similarly, on the PT of erythrose, where two OH are same, I developed the third chiral center on the top. OH to the right is called ribose, and that is D because the bottommost OH is at the right. So that is why it is capital D, but it is minus. And you can assign the configuration starting from 2, 3, 4. You can jolly well. And when you make the OS to the left, this is arabinose, this is ribose, that is minus, and this is ribose. Both are D, and they are diastereomers. They are not mirror images. I have only changed the configuration at the top carbon, keeping the bottom two chiral centers identical. Similarly, on the PT of triose, OH, H OH remaining on the both sides, on the opposite sides. In the back of 3 O's, we are developing another new chiral center, OH to the right, which is called xylose. And fortunately, after so long time, we were waiting for a plus. D is plus, and here D is again minus. OH to the left. This is called like so. These are called aldo pentoses, and there will be 4 pairs, 4 into 2 8, 2 to the power 3 8, so there will be 4 pairs, ribose D and L, capital D capital L, ribinose capital D capital L, xylose capital D capital L, and lyxose capital D capital L. This is called aldopentose. Let me write down here. And the enantiomers in each case has not been drawn. Similarly, we come to our favorite glucose. On the PT of ribose, if you generate the topmost chiral center OS to the right is allose, which is plus. थोड़ी देर के बहुत देर के बाद plus आ गया है, and OS to the left is also plus, but both are D because the bottommost chiral center OH is lying to the right. Altrose, allose and altrose. And now on the PT of arabinose, our glucose is its ancestor aldopentose is arabinose. And synthetically, we can convert arabinose into glucose. Not we, but Kiliani was the first scientist to convert arabinose into glucose to confirm the structure of glucose, the stereo configurations of glucose. So on the PT of arabinose can have 2 possibilities. One, OS to the right, that is our favorite glucose, and that is D, and fortunately plus. And OS to the left is mannose, is also D plus. And in the PT of xylose, we have OS to the right called gulose, D minus, and then idose, D also minus. And in the PT of lyxose, we have OS to the right, galactose, which is plus, and then talose, OS to the right, talose. So these are the 8 pairs, 16, 2 to the power 4, 16, and 8 pairs. One of them is our favorite D, and the corresponding capital L we have not drawn. You understand?
Yes, sir.
And interesting is, if in a carbohydrate, if only it differs only in one chiral center, all these 8 are diastereomers. All these are diastereomers of each other. Right? They are not enantiomers. None of them are enantiomers. Enantiomers had not been drawn. Now, if 2 carbohydrates, 2 simple sugars, or any such similar compound, they differ only at one chiral center. The all remaining chiral centers are identical in configuration. The special term is called epimers, is used. Epimers, I have written here. See, this is fructose, which is found in many fruits. Fructose has a keto group. There are only 3 chiral centers. The topmost is CS2OH, and the second one is also a chiral carbonyl group, is a ketone, and the bottom is also CS2OH. This is fructose. The formula is same, C6H12O6. There are 3 chiral centers, and up to it both, they have arabinose structure because OH to the right, and this one is to the left, and this one not arabinose, तीनटा chiral center जो थिला, yes, arabinose structure, yes. तापरे आउ गोटे chiral center develop हेलानी. It was a keto and then CS2OH. So yes, arabinose, both have arabinose structure. And just see, D, why D? Because the OH at the bottom is at the right, but it is minus. Therefore, it is called levulose. Very fondly, fructose is called levulose, and glucose is called dextrose, because it is dextrorotatory. D plus is fondly called dextrose, while fructose is called levulose because it's levorotatory. Now epimers, I told you, epimers are diastereomers, no doubt, because only one which differ only at one chiral center. Others are same. For example, glucose and mannose. You know, when new chiral center is generated, OH to the right and OH to the left, they are epimers. Glucose and mannose, they are epimers differing at C2. But glucose and galactose are also, if you look, compare, you will find the difference is at C4. They are also epimers. Not necessarily C2 will be changed. Any one chiral center will be same. Sorry, any one chiral center will be different. Others are same. So glucose, if you see to glucose, now see glucose, fourth carbon, 1, 2, 3, 4, OH is lying to the right, and see galactose, OH in the 1, 2, 3, 4, OH to the right, and this is 1, 2, 3, 4, OH to the left. Others are same. OH right, OH left, and this is the difference here, OH left and OH right, then again same. So glucose and galactose, they are epimers. Glucose and mannose, they are also epimers, but they are ancestral, aldopentose, this is made up of, arabinose, and while this is made up of lyxose. But glucose and galactose are also epimers. Similarly, glucose and galactose, glucose আসছে xylose group. Glucose and galactose, they differ in carbon number, C3. Others are same. Now, I will not talk about Howard formula. This will be very, very inappropriate at this time to talk more about carbohydrate. But let me tell you, epimers, diastereomers, differing only at one chiral center. Mostly used in carbohydrate chemistry. For example, glucose, obviously I will not make further complicated. Only one example I give. They are diastereomers. They are not enantiomers. So the C2 carbon, this will be OH to the left. This is also capital D. This is also capital D. And others are same. This is D plus glucose. This is also D. But I don't know. I have to look again. Galactose. Mane ache tomar kono? Sorry, mannose. This is not galactose. This is mannose. D plus. Say B plus. More mane ache. Same thing. These are epimers. Same thing. Galactose re 4 number ta different. Got it?
Yes, sir.
Yes, sir.
I will congratulate you because the level of patience that you are exhibiting is not seen so commonly. Very uncommon. ठीक है, दिखाएगा लगे? Nine. It's correct. Yes, D mannose is also plus. I was just checking. Now, alpha amino acids is very interesting, which are produced from proteins. The reduce R, this is variable. This R is variable. And there will be carboxylic acid, COH, and will be HNS2. Here, NS2 is taken in place of OH. To the right is D. In natural alpha amino acids, it is always L. I am showing alpha amino acid can be D. Synthetically, you can prepare D. capital D, OH can be on the right. Its configuration you will tell me now. But in the protein, the natural alpha amino acids from proteins, all are L. The NH2 will be lying to the left. And the oxidized group is here, the reduced group is here, and H will be here. So tell me what is the configuration in this case? All protein are all L, capital L, because NH2 lying to the right, to the left, I'm sorry. All alpha amino acids have the configuration L, capital L. Whether it will be plus or minus, I am not interested, I don't know. I don't know. This is R is very general. There can be many things. If R is methyl, this is called, alanine. And if R is H, it is achiral called glycine. It's achiral. It's not a chiral molecule. So out of 20 amino acids, only 19 are chiral. The glycine, which is a natural amino acid, is not chiral. It is achiral because R jagare H asibo. Dita group saman hegala mane seta chiral noy. It will not respond to ppm. So এটা কোন হবো? R না S configuration কোন হবো? Supposing R, carboxyl is an amino is number 1, carboxyl is number 2, and this is 3. 1 to 2 to 3 clockwise, and hydrogen is in the horizontal position. So golden rule. So কোন হবো এটা?
Correct.
So all have out of 19, out of 20 amino acids, glycine is achiral. Why? Because R is equal to H. Other out of 19 chiral amino acids, all are L. Out of 19 chiral acids have L configurations according to the capital D capital L concept. But 18 have S configuration. The absolute configuration is S. And 1, that is cysteine, has R configuration. This is very interesting. I'll show you that R, how L, since NH2 is in the left, it is L. But this is CH2SH. Now tell me, between carboxyl group, which was always coming ahead of every carbon bearing group, now compared to CH2SH, which is senior? Okay, amino is number 1, but in all other cases sulfur was not there, so number 2 was carboxyl. But here, which one is number 2, Miss Tripathi?
The
Miss,
COH.
huh?
The COH.
Are you kidding me?
No, sir. CH2SH.
ମୁଁ କହୁଛି ମିସ୍ ତ୍ରିପାଠୀଙ୍କୁ, ଏଟା ପୁରା ଏସ୍ ଲାଗିଛି, କାର୍ବନ ସାଙ୍ଗରେ ଗୋଟେ ଏସ୍ ର ପଲ୍ଲା ଭାରି ହେଇଯିବ, 3ଟା ଅକ୍ସିଜେନ କୁ ଗୋଟେ ସଲଫର ମାତ ଦେଇଦେगा. तो which is senior, carboxyl or CH2SH? କେତେ ମୁଁ କରେଇଛି?
The CH2SH.
तो घुमौଛ, you are dosing. So this is number 2 now. This is number 3. So 1 to 2 to 3, this is going anticlockwise, and golden rule, this is R. This is R cysteine, but it is L. No doubt it is L, but R configuration. The only amino acid which is R is cysteine. Other 18 are S, but all are L. Got it?
Yes, sir.
Now
Yes,
with
sir.
this, we think we are almost at the end of our program. Yes, line structure. That is the end. Line or zigzag representation of optical isomers. आजिकली सेटा बेसी पॉपुलर हेची, सेटा कोन? The carbon atoms are kept in one plane in a zigzag conformation. The conformation has to be zigzag. Eclipse conformation rohini. A CC bond empty, empty. That is the most stable conformation. I'm a conformation पढ़िने पढ़िबा, but time to time मु कहूची तमर कानरे बजौची carbon atoms are kept in one plane. That means plane of the paper with zigzag conformation. And the two other groups, the two different groups attached to chiral centers are shown with ways, one ways and broken line. Gote ways, gote broken line. Broken line will tell you that it is lying below the plane, and ways will tell you that it is lying above the plane. For example, we will be drawing tartaric acid. That we are doing like this, mesotartaric acid. Whatever you can do, OH same side, HH same side, COH same side. We could have also kept COH here, OH here. So because SR and RS, they are superimposable. Jahu plane of symmetry thila mane hela. Eta meso taku ame kemti kariba. Eta carbon, eta carbon, eta carbon, eta carbon. So ute zigzag ago kariba. ये कार्बन ए दीटा कार्बन कायरल एटा COH अकायरल एटा COH अकायरल ताकू लिखि दबा एठी जो रहिला एठी गोटे करिवा वेज गोटे करिवा ब्रोकन लाइन एटा ऊपर अछि माने गोटे वेज जो पटे जो सेमती किछि माने नाही जो एपटे करिवा वेज गोटे ब्रोकन लाइन दीटा को ऊपर एटा दीटा को तळे बट गोटे वेज गोटे सो जदि मु करिवा को चाहूची मेजो ताहले H because ये तार zigzag conformation रे ये COH COH opposite रहिला माने HH भी opposite रहिबो OH भी opposite रहिबो नहीं H opposite रहिबो गोटे wedge माने गोटे broken line हेले opposite दीटा जाको wedge दीटा को broken line हेले same side so गोटे H अछि ऊपरे गोटे H अछि तळे so they are opposite आ गोटे OH अछि तळे एठी OH अछि ऊपरे ultimately there is a plane of symmetry and it is zigzag conformation is anti-conformation and that will be meso. You got it?
Yes, sir.
Yes.
And you can also assign the configuration. Yes, Ms. Tripathi is very clever enough. You can do it. Here hydrogen is above the plane. You can apply the golden rule. Number 1, number 2 is carboxyl, number 3 is budha. So number 2 dekho, number 3 budha ko dekho. 1 to 2 to 3 clockwise. Buluchi and golden rule, hydrogen is above the plane and this is S. S hele eta nishchay R hobo dekho. कारण এটা আমি জানিছু মেজো এটা আর হবো number 1 is OH then COH then Buddha 1 to 2 to 3 clockwise and hydrogen is below the plane here you will apply the normal rule to make it R. Yes or no?
Yes, sir.
Yes, sir.
And make one change. Anyone say zigzag conformation ray आगो ड्रॉ कर दियो गोटे वेज सबु जगह रे सबु कायरल सेंटर रे गोटे वेज गोटे ये ड्रॉ कर दियो देन मेक वन स्विच एठी एक्सचेंज कर दियो एठी के H नहीं आसो एठी के OH नहीं आसो नाउ OH H OH they are in opposite side H OH are in opposite side सेठी कोन आइडेंटिकल ग्रुप्स गुडा ऑपोजिट साइड थिला एठी नॉन आइडेंटिकल ग्रुप्स ऑपोजिट साइड रे अछि so there cannot be any plane of symmetry or center of symmetry this molecule so OH lying on the same side both lying below and HH both lying above on the same side while COH lying on the opposite side so it is not possible to visualize any plane of symmetry or anything excepting a C2 axis of symmetry if you just rotate about a vertical plane vertical axis then you will regenerate. Are you following me?
Yes,
Yes, sir.
There is a C2 axis here so I'm doing this running a risk of telling something which you are not supposed to, supposed to learn at this stage, because you guys are very, very good. This is active. I don't know. You can say this, if this is R, I have not touched this. So if this is S, this is, I have changed this one, so this is S. So this is SS tartaric acid. Yes or no?
Yes. Yes, sir.
And if you switch at each of the chiral center, then you will get RR. Same thing. Supposing say mu kahibi 2,3 dichlorobutane ro tome RR configuration lekho. This is a symmetrical compound. Tome RR configuration ta draw karo. Same thing. Butane mane chatta seti methyl jagare. ये जो methyl थिला एमती करो कि सेमती करो, एमती करो कि एमती करो, जहाँ भी करो सेठी एमती करथिले एठी एमती करिवे, एठी मेथिल एठी मेथिल, दरा कायरल, ए दीटा कायरल. सो गोटे एमिति गोटे एमिति गोटे एमिति गोटे एमिति देला परे तमे एमिति दबो जे यू विल गेट फर्स्ट ट्राई फॉर एक्टिव. सेम सेम साइड रहिबाकू पड़िबो. तापर जदि भूल हे गला एसएस हे गला त उल्टी दियो. धर ये भी सेम साइड रहिबो, अपोजिट साइड, ये तो अपोजिट साइड रे अछि, तेणु बाकी जो क्लोरीन क्लोरीन सेम साइड रहिला एंड एच एच सेम साइड रहिला. देख एटा कौन आरआर हैला कि एसएस हैला, जदि नाही दीटा को स्विच कर देबी. नंबर 1 क्लोरीन, नंबर 2 बुढ़ा बुढ़ा सागर क्लोरीन लगी, देन मेथिल 1 2 2 2 3 क्लॉकवाइज. अरे रे 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 हाइड्रोजन तो पछरे अछि, नॉर्मल रूल आर हैला, एटा निश्चय आर हबो कारण हमें जानि छु एटा आर हबो. देख क्लोरीन नंबर 1 नंबर 2 बुढ़ा नंबर 3 क्लॉकवाइज, नॉर्मल रूल आर हैला कि नहीं. एक छेक करे हे गला. जदि न हैला मेक वन स्विच एट ईच कायरल सेंटर. ठीक है.
Yes, sir.
Yes, sir.
Now let me show you in my original file, which I will share with you today. I will be browsing through from the beginning. For only this file contains the materials for optical activity having chiral centers, not chiral axis. There will be another file. I will, this from the middle 39. We have done this. We have done EE, absolute and relative configuration, no correlation, Wedge formula, Fisher projection formula we have done, CIP rule we have done so many times. Now you could get Z is C is greater than E and R is greater than S. You know what is the meaning? D is greater than H. Yes or no?
Yes, sir.
Number of isomers. Oh yeah. Now you can rethink that. Supposing you are given to find the total number of isomeric alcohols from the formula C4H10O. You will be doing say structures, but never forget. I have been sounding to you long before that try to find a chiral center. Here in butan 2-ol or sec-butyl alcohol, you find a chiral center. So one will be more, right? 4 structures, but one of them will be chiral, so it will be having a DL, so plus 1. So there will be 5. Understood?
Yes, sir.
I have not included ethers. I only have asked isomeric alcohols, which will be optically active. This is very simple to find a chiral center. This is not chiral because methyl are identical, so this is achiral. The second one is chiral because this carbon is this carbon is chiral because connected to hydrogen, OH, methyl and hydroxymethyl. So this second one is chiral. What about this? This is chiral connected to vinyl. This carbon is chiral connected to vinyl, methyl, hydrogen and carboxyl. And this is also, no, this is not chiral. Bonded to ethyl. So both are same. So this is not a chiral center. This is achiral. You understood?
Yes, sir.
Now, I forgot to tell you one thing, that no, সেটা geometrical isomerism সরলে করিবি, geometrical isomerism সরলে EZ isomerism সরলে সেটা করিবি. So a molecule can have both EZ as well as RS. In some place it will be R or S, in some other place there will be a double bond which is having two different groups at each sp2 carbon. So you have to assign in terms of RS for chiral centers, in terms of double bond you have to mention E or Z. Toying with the formula, I have done it yesterday. Toying with the formula, two chiral centers symmetrical, and we have done active forms, diastereomers, unsymmetrical structure, thioerythro concept we have done, and yes, so many examples we have done, and also we have done also so many examples. Three chiral centers with the pseudo chirality we have done, and I have shown you how you generate this pseudo chirality phenomenon, and then the formula for getting the number of optical isomers and mesoforms. Zig-Zag notations also we have done, and also assign the configuration. Now see, glucose can be shown in a zigzag form. Now this side we start from hydroxymethyl here, this one, and the last one is, and this is all carbon atoms put in one plane in a zigzag manner. There are four chiral centers, and one wedge, one broken line, wedge, broken line, and you give in such a manner, you will find one, the first one, second, second carbon is R, third carbon is S, and fourth carbon is R, and fifth carbon is R. You place it in such a manner. So this will represent the zigzag or line formula of D-glucose, which is fortunately plus, right? DL notations we have done. Epimers, only Haworth formula will not be doing now. Alanine, all others are S. All others are S, excepting cysteine, which is R. This is the end. Bye-bye. Bye. Those who are watching, so many guys are watching. You are watching, you are not giving like sign. Of course, I can't demand a like sign, a like button, unless and until you really like. But many of us, we really like, but we don't have time to encourage that person who is, expecting a like button. Do that, and if you have not yet subscribed, consider subscription. Bye bye. See you. I know this is the end of our program into 2024. In 2025, maybe from the first, you must watch. Those who are watching from outside must have a watch to our website www.theuranium.in. The Uranium without any space. Theuranium.in. We will be getting, notification. Bye. Hello.
Yes, sir.
Nani?
Yes, sir.
Vokalani?